Good morning, everyone. We'll be getting started in just a few moments. We're allowing people to join in. Folks are starting to come in now. That's good. You got a fellow European on there.
Oh, great stuff. Representing.
That's right.
Although very unfortunately for us these days, whether you qualify us as European anymore is an open question. But let's not bring politics into it.
Yeah, right. But my Italian accent is better.
Excellent.
Yeah, just one more moment. We'll wait and then we'll get started. Okay, well, good morning, everyone, and welcome to Great Data Minds. We got a great event planned here today. Joining me is our guest advisor, Eric Topham. He is CEO and Data Science Director at the Data Analysis Bureau out of the UK. Welcome, Eric.
Thank you very much, Mike. Thanks for having me. It's a pleasure to be here. It really is.
Yeah, well, I'm really excited about what we're going to chat about today.
Absolutely.
Looking forward to it. So a few housekeeping items for everyone. Please use the chat to share your observations with each other, with Eric and myself. Also use it to ask any questions, and we'll keep an eye on the chat window. And you know, during the course of our dialogue, we'll stop and take some questions and see if we can get stumped by you all out there. So again, welcome, Eric. Tell us a little bit about the Data Analysis Bureau.
Sure, yeah, absolutely. So TDAB is a data science and engineering innovation company. So we have for the last sort of 3 to 4 years specialized in developing bespoke high-end machine learning solutions for other businesses. We have also established a strategic R&D partnership with Imperial College here in London. So we actually also undertake quite a large amount of sort of academic research, but sort of very much applied into industry in terms of how we develop certain machine learning solutions in that space. And yeah, we're growing wonderfully. You know, we work in a very diverse set of industries. We're not sort of particularly specialized, and we are now sort of starting to expand ourselves. We're sort of going through an exciting funding round and expanding ourselves into commoditized ML products. And so it's a really exciting time.
Well, you know, and it seems like the year 2021, and I don't know if this is a result of the perfect storm of the latent demand that built up throughout 2020 and or the many organizations finding themselves at that tipping point, right? Where it's like, holy cow, we have to figure out how to be nimble and agile and change our business models with agility. So I'm seeing a lot of evidence And a lot of research coming out of the likes of McKinsey Research Institute and others that 2021 is going to be the year where machine learning and AI really starts to take hold on a more aggressive pace. And I think a lot of companies are waking up to the potential benefits. But I mean, what's your sense? Are they achieving those benefits?
Yeah, I mean, so for sure, I think the first thing is just to kind of unpack that slightly, which is to say that I think you're absolutely right. That the word on the street, if you like, is that 2021 is the year, the inflection point that AI. Well, I'm always a bit cautious with AI, but let's say machine learning applications really start to scale. And I think that it is fair to say that we're now sort of starting to see an inflection point, if you like, within the data and AI supply chain, right? There are enough individual organizations creating enough of the components for others to then build and scale if they have the the knowledge to do that. That then leads to the second question, which is are organizations now already getting the benefit from that they should? And I think that arguably the answer is, for the vast majority, still no. So partially I think that's down to the fact that some of these tools that are appearing are still new. Some of it is that just the entire domain is still new to the vast majority of potential adopters and users. But you're right to mention some of that research. There was something that I was reading not so long ago from Accenture, that some research that tried to quantify what the gap was, if you like, between those that are sort of playing with machine learning projects and those that are successfully managing to scale them. And it's relatively shocking, really. I mean, the return on investments are sort of less than 30% for those that are sort of playing and carrying out a lot of investigative proof of concept type projects. And for those that are successfully scaling, you're seeing sort of 86% plus, depending on the industry, in terms of that ROI. And I think they even managed to kind of quantify that on average as a sort of $110 million gap between those scalers and those those sort of still just doing proof of concept, not
The
to mention
dabblers.
people that aren't doing anything. Yeah, exactly. Yeah.
So definitely there is some worth out there. At least the researchers are telling us that, and they are backing it up with a lot of evidence-based research, a lot of surveys I've been seeing. So you mentioned POC. So what are we talking about here with the POC cycle?
Yeah, for sure. I mean, so proof of concepts, and I think we need to again be a little bit careful. Proof of concepts mean a lot of things to a lot of people. To some people, that those are very sort of limited technical spikes where we're trying to de-risk a project before we undertake a full project. In other cases, quite literally, we're trying to prove a concept. That something can be achieved with the tools and material that we have at hand. So from my perspective, proof of concepts, it does really depend, on the project. In some cases where we're doing a little bit more of an applied build, it might be those technical spikes, and that's not really the case that I'm sort of thinking of here when I talk about the proof of concept cycle. It's those kind of more exploratory pieces that are there to try and understand whether something is actually feasible in the first place. And you see this a lot, these kind of sort of reduced scope projects that are sort of carried out on a sort of a bit of a whim, and are there to try and explore whether something is in the longer term going to be achievable. And it's a bit of a double-edged sword, because on the one hand, it can be a powerful thing, because if it's successful, it really can drive a lot of buy-in from your stakeholders around, the fact that it is worth investing in this idea that somebody's had that may then have return on investment for the business. The flip side is that if it fails, almost invariably that's viewed, particularly by non-technical stakeholders, as being a failure that indicates that something is absolutely not possible,
Mhm.
rather than understanding it in the sense of, here's what we learned from this failure, and therefore we're more likely to succeed in a second step. So when we talk about this proof of concept cycle, what I've seen a lot, both in other organizations where I've worked and with customers, is this inability to get out of doing one sort of proof of concept after the other, and not sort of progressing the project up those technology readiness levels. And that's what we mean by, that kind of, failure in the eyes of the stakeholder that then returns you back to kind of step one in that snakes and ladders game of then having to come up with a new idea for a new project and trying something else, rather than managing to get yourself out of that cycle and, progressing the idea and eventually, developing a scalable solution into production.
So I'm sensing that there's the risk of not being able to escape the POC cycle. Right?
Yeah, exactly.
Is there an approach around that, or what?
Well, there are, I guess, a number of approaches. It's a multi-pronged solution, I think. So some of it is going to be, technical in terms of how you actually go about executing that proof of concept, and about how you sort of try to not overreach. Some of it, of course, is going to be how you do your stakeholder management and how you achieve buy-in. But I think that one of the key things that I see time and again is people trying to overreach in their proof of concept, particularly sort of less mature teams that are going to have an idea, don't actually really explicitly know how to solve it, go and do a bit of research, find themselves on, towards data science, Medium, some really good articles, but kind of extrapolate one very complex solution to a problem into being the solution that they should try. So to really simplify that, you quite often see cases where people have, let's take survival analysis as a problem, right? I want to do a time to event prediction about the failure of a part in a manufacturing machine. And I've seen this a couple of times actually, where a team has automatically jumped to the idea that what they need to use are recurrent neural networks with some funky filters in front of them, Kalman filters, and they're going to model complex probability distributions, only to find that the data they've got isn't really suitable. It's not in sufficient, not in sufficient volume. They don't have enough events, so on and so forth. When in fact, a much more simple solution, a much more traditional, perhaps less glamorous solution like a Cox proportional hazards model might have actually worked very nicely. And while it wouldn't be the ultimate end solution that you might develop, it would achieve what it's meant to achieve, which is to, on the one hand, get that buy-in from your stakeholders, and two, teach you a bit about what's likely to work, what's not likely to work, and how you might best iterate the model that you develop as you sort of progress the project.
Yep. So a couple of things are hitting me. As we've talked earlier, we're very much proponents of taking a lean, agile approach to your analytics program. And part of that is buying into the lean side of the house, where continuous quest for improvement, continuous quest to innovate and explore, which I find to be incredibly valuable, because we want to vet these hypotheses out as quickly as possible, right? And you touched on another thing that I've seen too, where we head down the road and we start making some significant investment in some of these models, only to find we don't have entitlement to the necessary data to feed and care and nurture and train these models. And so why do so many models seem to perform really well in development and then they belly over in production?
Right. Yeah. So this is obviously one of the fundamental troubles that people have, particularly when they're new to data science projects. And I think a lot of the time when you see this complaint, there's an element here of a lack of sometimes maturity and experience from the teams that suffer this, where what they haven't fully understood and appreciated is that machine learning models learn distributions fundamentally, right? And the systems that capture data are capturing that data as information about the world that we observe around us, and the world doesn't remain in one static state. So if you develop a machine learning model based off some historical sample of data, you're effectively using a snapshot of the world as it was at that time when that data was collected. And so if you train a model, I'm very much sort of talking about supervised machine learning here to a large degree, but you can sort of extrapolate from here. If you train that model on that that data set that is if you like, a snapshot of the world at that particular point in time, that model may be perfectly valid for that historical set. But if the world, if you like, has moved on, to use layman's terms, and the distributions that exist in the data that is then captured in your live production stream are different, then your model is no longer, it's maladapted now for the distributions that are in that live data set. And so you'll get spurious inferences out from the model when you test it back against your test set. So that kind of fundamental understanding about concept drift in live production data streams is key. And then what that leads you to understand is that, in fact, training and testing models in development is just a small, to some degree, almost simple part of the process. In fact, there's an enormous amount of overhead that happens in terms of the engineering that's required to actually implement those models into production, to maintain them, develop them, monitor them, and manage them as an active, almost a live, living thing, right? And that's, I think, a step that's very, very often missed by teams that are new to the data science and engineering in game. And since most people are new to it, it's not surprising that lots of people report that they have issues. And I think that this is a kind of a fundamental problem with the current sort of trend in machine learning, particularly when we look at deep learning, which is that these models, while being very complex, are also very febrile, if you like. It doesn't take a lot to actually upset them. I mean, for those that know about adversarial attacks and the such like, you'll know that there are some pretty famous cases that people have demonstrated where you can fool image classifiers into thinking that a panda is now a dog or something, right? And even that is not a big difference. So there's a kind of a more fundamental problem to, I think, machine learning architectures and the sort of theoretical developments about how we build those. But there's, I think, a more practical aspect, which is that there's a certain maturity that people need to acquire about how you actually manage these past the point of deployment in order for them to be robust and therefore for them to return value to you.
Yeah. So there's this concept, or yeah, I'll call it a concept for lack of a better term. When I'm training and then testing my models with a historical data set, there's a need for the awareness that data has an ingrained bias in it. Yeah, and we have to be intentionally aware of that.
Yeah, absolutely. And I think that the trouble is that a lot of the time when you sort of, if you're starting out in data science, you go and read about how you train, test and validate your models. I think that's, what you read most of the time is just the bare minimum. And in fact, we can really beef up the test harnesses that we use at the end of, the end of that process. And we can, do much more in terms of sensitivity testing and the such like to try and understand, how the performance of that model is likely to vary if we get disturbances within the within the production feed. And I think people get fixated with the idea that if they achieve 82% validation test accuracy on their holdout set, that they should expect to always see that exact number in terms of the accuracy percentage on their production set. But the reality is that number is likely to vary somewhat over time. And so there's just kind of these, appreciations that people need to kind of build into their processes and thinking.
Yes, and you mentioned when I'm going to production, the mechanics around the model itself. There's mechanisms on the sensing. You mentioned telemetry. You mentioned monitoring. Can you expand a little bit on what that final leg ecosystem is? Because my sense is people are missing that point.
Yeah, for sure. So there's a number of things, and really, actually, none of this is sort of too much of a mystery if you've sort of been around, the DevOps world at all, and continuous integration, continuous deployment processes and tooling. So a key part to your pipelines are going to be orchestration tools. So for instance, Azure Data Factory with Microsoft, and so there's going to be some orchestration there, about whether you're running sort of streaming or batch jobs with your data that's going to the production model. You've then actually got obviously your model monitoring tooling. So there are now sort of some very nice tools that are coming out to do that, distribution monitoring in the live feed, looking for concept drift. There are also some mechanisms that you can build to actually use some machine learning itself to detect whether the distributions in the production feed are actually different to what you had in the historical data. So effectively building an anomaly detection pipeline to monitor the production pipeline. And so from that, you can either put on sort of manual monitoring tools, if you like, so feed some of that to some dashboards so that people that are doing that support can actually quite literally see the pipeline themselves, or of course you can build automated processes into that. And then the key thing, of course, is to have kind of really tight CI/CD processes for doing new releases to production of new models that you may retrain. And you often see a lot of the time that people just go about this by kind of just retraining their model periodically, but that seems to be a somewhat brute force approach. That may not be necessary. If fundamentally the distributions in the data hasn't varied, and therefore there's no justification for actually retraining your model on a fresh historical period. But that is one approach that can be taken, or you can do it, of course, based on some criteria from within the data.
So some kind of triggers, and the action I'm taking then is, hey, I need to potentially do a challenger model to the existing one, or
of course, so I guess from a sort of a life cycle perspective, you would expect to have either an automated or manual retraining process. And this really kind of depends, I think, on the maturity of the pipeline that you've deployed. So early days, for the most part, what we would recommend and see is that that's actually a sort of data scientist-led manual process of effectively, as your production pipeline is running, doing some retraining and validation and testing. And then if you find that according to whatever test criteria you put in place, that you have a model that you deem to be deployable, then you would replace that. But with time, it would be normal that you actually look to set that up as an automated process where you have some automated retraining on those triggers of an ensemble of models, for instance, that if you exceed some criteria of performance, get automatically or semi-automatically deployed. For sure.
I got you. Okay. So in your opening, when you shared with us what the Data Analysis Bureau is about, you mentioned that you're doing application and you're doing research. Are some companies having a fundamental issue in confusing the application data science versus research data science?
Absolutely. So this, I think, and I think this is, people are starting to wake up to this, thankfully. But I think for a period there was, firstly, people got really excited about data scientists and didn't really think about the engineering side of things. Exactly. And the second thing is that they equated, data scientist to needing, a PhD in quantum physics to come and work for them when their main business problem was customer churn, right? And it's just unnecessary. And there's a couple of issues to that. So if nothing else, the poor old quantum physicist is probably going to get bored after a period of time. And I think it is worth noting that actually there's a very high rate of churn amongst data scientists, that have come out of academia and then taking data scientist roles and then leaving again. And I think some of that comes down to expectation. It's also a problem for the business because the business has got some buy-in to fund these roles, and then they don't necessarily see the output that they expect, and most of the time that's because the data that they actually have is not in a state that it's going to be particularly useful for data scientists to make something, something of. And the second thing is that there's two really different set of skills here. There's the hardcore research data scientist who's suited to understanding the theory and then, creating novel, algorithmic architectures. And then there's your applied scientist who has more of an understanding in the domain knowledge of the industry that they're in, how those processes work, the attributes of the data, and then has a toolkit, if you like, at their disposal of algorithms and other tools where they can combine those, if you like, based upon their domain knowledge to solve actual business problems. And I think this has been that's what most people need. And for a while there, people have just been going out and hiring sort of very academic data scientists. And so depending exactly on what you're doing, the purpose of your business, the function of your business that you're hiring for, you're going to need rather more one of those things, than the other.
Yeah, and there's a lot of platforms that are coming out, especially this past year. I saw this like top 21 startups to keep an eye on, and there was a lot of focus in the machine learning space around deploying low code or no code kind of environments to enable data science, which I'm kind of excited about that because I'm a proponent of self-service analytics to get the scale, to vet those hypotheses and all that. But is there still a place and a need for that deeper quantum physics oriented type of research to be going on?
Yeah, so I think there's a couple of things actually. I'll just unpack that one again. So there clearly is a place for the deep research scientist. Companies that undertake proper R&D that want to embed complex machine learning solutions into their products quite clearly need that capability. If we look at the sort of the more applied side, when we talk about those low code tools, I'll be honest, I'm still myself a little nervous about this sometimes, because while that's a fantastic idea and so there's some great tools that can kind of really accelerate people, I think that when you have these kind of either AutoML tools or those low code tools, there's a loss of ability to kind of fundamentally validate what you're doing. And what we see is that data science a lot of the time still takes an awful lot of human intuition and expertise around the data. And going back to that question about why do some models fail in production, I think a lot of the time it's because something has been missed about the properties of the data that you're working with. That if you don't have an ability to dig deep, you don't need to always dig deep, but to dig deep, then you're going to miss that. And so I think that some of the best consultants that we have at TDAB have come from an academic background, but they've understood how to apply themselves in that more kind of applied scientist role, rather than wanting to live in that research scientist role. So there's a role for both. It's just knowing when to have each one and how they're best suited and how to best point them in the right direction. Yeah,
you mentioned some data scientists will get frustrated, the more highly skilled because there's just no curated data for them, right? They can't get their arms around the information that they need. I was at a university, this is several years ago, and I was asking them, where's their value as an enterprise? And they were a research facility, medical research facility, and they were a university. And I was trying to get out of them whether it's the donors, the donations from the alumni, is it the student, what's it, tuition? Thank you.
Oh, right, the tuition fees.
Is it the tuition fees? I said, where's the value? They said, our value is in our curated data, because we are getting the best analytic talent in the country coming to us because I have curated data. And that kind of leads me to, a lot of companies are hearing about this data engineering concept and whatnot, but where does that fit in machine learning?
Yeah,
right?
well, I think it's actually critical, and this is the thing. Like I say, that people have had their hiring almost the wrong way around. Everyone got excited about data scientists, whereas what they actually really needed were data engineers. So data engineers, very broadly speaking, serve two functions, right? They build, the infrastructure and what we call machine learning pipelines that take the data and do the necessary pre-processing, transformations, cleaning, et cetera, to get it to a state, firstly, for some data scientists to start to develop some models. So that would be your training pipeline that they're going to build, and they're going to work sort of hand in hand with the data scientist to get that data into an optimal state for training models and testing and validating them. And then the second step, which a lot of the time, even when people do realize they need data engineers, forget about, is that second step around putting things into production. So there comes a point where the data scientist has done their bit, they've done their model development cycle, they've done their deep dives around validation and such like. They're happy they've got a model that's good for production. It now needs to go into production. And so the data engineers are there to build those production pipelines to ensure that the data that's arriving to the model is robust, that it arrives in the same form as it was trained on, and that we have all of that tooling that you mentioned previously, for doing the monitoring, and the CI/CD processes are all in place. So in fact, if you think about the overhead in terms of building a machine learning driven solution, actually the vast majority of the work is attributed, we would probably say, to the data engineers, plus a bit of architecture work as well. And the data scientist, while they do a very difficult job in terms of the total contribution to that whole solution, it's actually just a very small part. So, these days when people say to me, I've got a business and I'm thinking of hiring a data scientist, I say, whatever you do, don't, hire a data engineer first, get your real estate, in shape, get the infrastructure in place, prepare the data, because otherwise all you're going to do is waste a data scientist's salary and also to some degree their the credit that you hold with them in terms of their frustration. And I've seen it. I've been to before running TDAB jobs myself, where I arrived as a data scientist, and you find that what you've got to work with is not what you were promised. And I've had plenty of friends that similarly got hired in as the first data scientist to an apparently innovative startup or whatever, and they get there and everything's a shambles, and what was really needed was a couple of really good engineers first to get everything in place, so that then the data scientist can add value later.
Yep. And a lot of large enterprises and small enterprises, medium size as well, have enterprise data warehouses of some sort, or data lakes, or whatever. Give it a name, right? Yeah. I'm an old school guy. Data warehouse works for me. I'm a data architect, right? I used to spend a lot of time driving out the specifications for getting the data organized, fit for purpose for analytics, and I thought I did a pretty darn good job. But then data science workloads come along, and there's another whole leg of feature extraction and feature engineering going on. So I guess we're missing the mark, maybe, or we need to have a little bit more knowledge and awareness of what a data scientist really needs when I'm designing and populating historical data into the data warehouse. Because why is all this additional feature engineering having to take place?
Yeah, for sure. So I mean, just very specifically around the question of feature engineering, the idea, of course, is that while we may have an initial set of raw features, if you like, with which we hope that there is some signal between perhaps a target variable and some explanatory variables. In fact, what we know is that a lot of the time, by combining, if you like, some of those features, doing some transformations to them, applying some functions to them, we can actually create features that are more, informationally salient, if you like, convey more predictive power, explain more variance, whichever sort of world you come from, how you want to present that, for a model that you're developing. It might also be that if you're in the game of building explainable machine learning models, then you're interested in creating variables that not only convey signal, but are meaningful to the person that's actually looking at the output of the the interpretations of local predictions.
Mm-hmm.
So that's kind of the rationale for doing it. As to the whole kind of it adds a whole layer of complexity. I do sometimes think that there's almost like a little bit of relabeling that goes on that causes confusion. So when you see quite a lot of chatter at the moment about feature stores.
Yes,
And
I was just going to ask you about that.
I think to a large degree, feature stores is a bit of relabeling of things that we would be familiar with data warehousing. And we're really just kind of putting somewhere convenient in a convenient format the things that data scientists really want to work with out of the box, and doing that perhaps in a scalable way, so that as we move from one development project to the next, we still have the same store full of features that we can go and pick from without having to rebuild pipelines. And I think that's the really key thing, a really core concept here when it comes to data science and development, is that this idea of machine learning pipelines where we can build reproducible, robust units within a pipeline, which we then don't have to replicate a second time when we create a new pipeline. So if I have two pipelines that are going to do complementary things in terms of their prediction, maybe I used the example earlier, time to event prediction for a critical failure in a machine, and I might also have an anomaly detection pipeline. I don't need to repeat those two. I don't need to copy those two pipelines twice. I can retain the same upstream elements and then just fork, if you like, the pipeline into those two streams, the anomaly detection and we might take different features into them. So this, I think, is really key, is this kind of idea of reproducible working, robust pipelines, and making them more scalable by design, and of course now containerization and the such like is now progressing that further.
Yeah, and I'm seeing data apps extending itself. Data apps automation is a natural extension to handle that last leg where I'm doing the feature engineering and feature store and all that. And it's funny, I'm glad you mentioned the feature store thing, because that was one of the startups that is out there. They built an automated feature store pipeline tool. So
and this is what I mean about the kind of the inflection point in that sort of data and AI supply chain, right? Like you have people that are specializing in trying to develop the best possible solution for a part of the pipeline. And I think that's what's kind of exciting, is that you've got all these people putting all of this effort into developing and optimizing these pipeline elements, and so that makes it a much more scalable thing for other people to come along and then adopt those individual components, find the ones that are optimal for their use case, combine them together. And that's something that at TDAB, that's our kind of our whole emerging strategy, is to get people to deploy faster by building pre-configured optimized pipelines that people can deploy in a sprint or two, rather than 3 or 4 months of bespoke building. Exactly.
So we got a question in from Francesco. Do you think that it's possible to prepare data for both the business users and the data scientists all in one shared environment, universally valid for everyone? He offered his answer. I want to hear yours.
Yeah, sure. So I think it's one of those questions, though, that you've got to caveat a little bit. So I think it really depends on the particular use case in terms of the organization, what it does, the maturity level of the two sets of end users. I think that quite clearly, if the data science workflow is tailored towards serving, shall we say, sort of predictive predictive business intelligence insights is kind of what I would call it, then I think that there we should be striving for a degree of commonality, because to a large degree there's going to be a prerogative to have models that are well explainable, interpretable by nature, and that should be the outputs of which should be understandable, and therefore the features, for instance, that we put into them should have some if you like, sort of tangible real world relevance. So trying to create an infrastructure where both can be served, because ultimately that machine learning pipeline may well actually be plugging into a business intelligence pipeline anyway, makes sense. But in other cases where the application is going to be somewhat more abstract, so where we might be building sort of deep learning pipelines for like I say in sort of industrial IoT, where anyway the data that's being used is fairly abstracted already, then it may be more appropriate, and where we get differences in the velocities of insight that we're looking for. So we might be looking for extremely high velocities for the actual sort of prediction pipelines that are connecting and automating with machines, but we might be looking at much lower velocities for sort of more reporting data. And so in that instance, we're clearly going to need to to segregate the architecture a little bit more.
Now, so sounds like your answer is yes, and you gave us a lot of good it depends to ponder. I'm picking up too that we at least need to be aware that there's this other stream of data being used and being created and used for machine learning, and we have to be aware that maybe there's business value in there as well.
Yeah, for sure.
Strive for it.
Yeah, I think the key challenge, about having all the data for everyone in one place is that ultimately there's to make data useful for machine learning, there's quite a lot of processing that goes on most of the time to it, and that may mean that we land up with data that is abstracted away from something that's in any way meaningful to a human end user. And so that's where the challenge comes in. And so the architecting of these systems really in the end has to be driven, if you like, by the end user requirements. And that's kind of another sort of critical thing that people don't think about enough. They build their systems, but without actually thinking to themselves, well, who's going to use this, and what implication does that have for the design?
Well, that kind of hints to me that there might be some wider considerations that companies are missing when they're planning for and designing machine learning driven systems. What are some of those wider considerations?
Yeah, so there's a few, and this is kind of more of a, I guess, like a sort of a business business processes question. So one of them is, how is this system going to fit into our existing business processes? And if it doesn't, how are you going to change that business process? And you do very strangely run into people that come to you and say, hey, I want to build, I need to do machine learning, I need to be more innovative, so on and so forth. And you say, okay, we'll build this, but you're going to need to change this business process. Oh, well, I can't possibly do that. You think, well, okay, I thought you wanted to be innovative. So that's one, that's kind of one key bit. And so to go with that is then, how do you, people often don't think about how do you evidence the impact, right? So, we started out talking about ROIs and this kind of thing, but those are incredibly difficult things to actually put your finger on and for certain say, it's this technology that we've deployed that is responsible in its entirety for this, for this impact. So, so very early on, KPIing, projects and functions of the business that are going to be impacted by these systems. And then the third one that links the business process is that what everyone always forgets is that for the most part, there's always a human involved somewhere in all of this. And while everyone likes to think of Terminator and super robots and God knows what else, in the end, as they are at the moment, machine learning systems are relatively febrile. And if a human doesn't want to use it, or if a human wants to break it, they will do so very, very easily. And so the thing that gets overlooked massively is actually engaging with the people who are going to be, like I say, the end users. And the problem that happens is that because these are new technology projects, very often the people that commission them are at the top of the organization, but the people that are going to land up having to use it are right at the bottom. So we've seen this, with TDAB a number of times, but one of the sort of the most famous ones for me was one of our customers is the world's largest can manufacturer, for a packaging manufacturer. And we built and designed a number of pipelines for trying to reduce the amount of spoilage that was running within occurring within their production plants. and we achieved some really nice accuracies. And it was just blatantly obvious that if you deployed this stuff, it would make sense. But one of the key insights that seemed so simple was that perhaps running machines at full speed isn't actually, in the long run, the most optimal strategy for your overall productivity. And so, after tens of thousands of pounds are being spent, there was a stakeholder meeting where, they finally agreed that it would be a good idea to bring in some of the operators from the factory floor to get their view on how such a system would fit in. And the immediate reaction was, well, we're not incentivized to do anything other than run the machines at full speed. So, we probably wouldn't actually, adopt this system very well. And so there hadn't been an appreciation from the customer, despite us kind of trying to encourage them, that right from the beginning, they needed to go and, engage with the end user and, do some, we needed to do some, some design thinking that took into account not just kind of the technical solution for how do you make this prediction ultimately very accurately, but how is that going to be interacted with, and how is it going to be, adopted by the end user? Because if they don't want to use it, they just won't use it, and you won't see any impact.
Right. Gotcha.
Simple as that.
I love the reference to design thinking. Very much a proponent of that as well as documenting with well-conceived behavioral stories. Because I'm trying to understand what is the behavior I'm going to influence, how am I going to influence it, how is that going to get evidenced. I loved it that you brought that up, so thank you.
Well, the other way to think about it, I think, is that, we hear all about how sort of AI is going to be, part of the workforce of the future. And, in any company, if somebody does, if one of the employees is disliked by everyone else, then it's not going to make for a great working environment, and that employee is not going to succeed, and everyone else is going to. So it's a very similar thing. If these systems are going to augment, if you like, human capability in the workplace, then they need to be adopted and therefore designed for the people that are going to actually interact with them and use them.
Julie will be happy to hear that. That's the humans. That's always been the foundation of our practices. Make sure we're taking care of the human, care and nurture, right? Customer centricity, those are things. So you mentioned a little bit, a lot of good business operationalization and adoption considerations. How about some of any key advice around technical considerations and practicalities of deployment?
Yeah, so I think that there's just a few like really basic things that you see just don't not happening sometimes. So version control, please use proper version control. Use good CI/CD processes. Use best practice. Do code reviews. I think that the other thing is really kind of a lot of success comes in the front part of the project. So not skimping on kind of some of that really boring stuff around, kind of deep diving the data, really trying to understand, its properties, the distributions in it, the quality for, for what it's, its intended purpose. And I think also, all effort to try and, spike some of those technical issues early on are very valuable. But I think the key thing is in order to be successful in the long run, we need to not be sort of scared of, deploying simple solutions very quickly and then iterating upon those as we learn. But I think it's a combination of the two. It's putting those, the tools that we've already talked about in place early on, along with those best practices, but then looking to kind of, deploy simple things that are more likely to work, right out the gate than try and, jump to those more complex solutions. So it's not a highly technical answer, but I think that to try and pin a very specific, technical point, it would be not as useful as I think sort of laying out some general principles for people to adopt.
Gotcha. Got a question from our old friend, Bill Lay. He's asking where, if anywhere, does model understandability come into play in the deployment strategy?
Yeah, so well, it actually comes before, I would say, model deployment. So good practice would be to actually try and, interpret your model and the predictions that it's, both at a global level and at a local level, so that the individual predictions that it's producing. And you want to do that because before we actually ever deploy anything, we want to know, why it's behaving the way it is, any biases it has in it, so on and so forth. So actually, I'd say it sort of comes before that. Then once you look at the production side, I think to a degree, we're interested in the use case, and of course we've got to be conscientious of the the type of algorithm that we might be using. So I think one of for me the key divisions is, as soon as I see a project that is about if you like, business insight and business process, there's immediately a need there to try and favour, explainable models, and to build into the pipeline some of that, the production pipeline, some of that explainability. Because, for instance, simply knowing that that a customer will churn in X number of days is great, but knowing the reason why the model is flagging them as a churn risk is even more powerful, because then you can do something about it. I think it is interesting that kind of machine learning sort of has traditionally, I think it would be fair to say, sort of focused intently on predictive accuracy, and whereas statisticians traditionally have been a little bit more enamored with the idea of inference, causal inference. And so there's now kind of this kind of, you can sort of see it coming now, this sort of looping back round in the machine learning world to the idea that we don't just care about our predictive accuracy. We actually care about why the model is predicting what it is. And in some instances, you might even argue that a few percentage points less in terms of predictive performance might be a good trade-off for a model that is more interpretable, because you can actually have a lot more insight and a lot more certainty in terms of how the model's behaving and so forth from that. So I think there absolutely is a place for it. There's clearly places where it's going to be more difficult. Again, if you're using sort of some of those sort of more black boxed deep learning architectures, but even there's starting to now be a variety of approaches to try and unpack those and get an understanding of why they're working the way they are. Counterfactual explanations being a very good one.
Is that the concept of explainable AI that I've been seeing out there?
Yeah. So very broadly speaking, there's a bit of difference between interpretable and explainable, but yeah. But I think that some of the really interesting stuff is in the addressing of the issue with neural networks that traditionally everyone likes to think of as being less explainable, but actually there are some interpretability methods, for instance counterfactual explanations, which not only kind of help solve that, but actually make themselves very applicable. So if you take counterfactual explanations, where effectively what we do is try and understand how the prediction of a model changes given some variance to the input, very broadly speaking, that's actually very powerful, because it gives us a method out of the box for effectively doing sort of what if scenarioing, rather than as well as understanding how the model behaves based on various alternatives in terms of input. So that's that's quite an exciting space.
Is there are you aware of any literature out there around your recommendation?
So Microsoft actually have a very nice package that's come out that's designed to sit on top of TensorFlow developed models called DICE. So I would highly recommend. There's a really nice repo. There are some more sort of layman's articles associated to that, and there's a couple of research papers from Microsoft Research that are worth looking at.
It's awesome. But you have just filled my head with knowledge today, Eric. In a sentence, what's your key takeaway for everyone to walk away with?
It's difficult because I normally have sort of 4 or 5 takeaways on this, but I would say prepare well, iterate fast, accept to fail. I think that's the sort of the three three things in a very poor grammatical sentence.
Yeah, we gotta help the industry change that dialogue a little bit. It's not failing fast. This is about learning. It's continuous learning, right?
Yeah, exactly.
Yeah, so I agree with you. Well, Eric Topham from the Data Analysis Bureau, thank you so much, sir.
Thank you very much, Mike. It's been
Incredible
a real
knowledge. It
pleasure.
was brilliant. Yeah. So everybody, thank you for joining. Visit our events page. We have a session coming up where I'm interviewing the Chief Data Officer from Microsoft to hear about Microsoft's data strategy. And then our Path to Modern Analytics workshop is coming up in May as well. So please check out our events page. We got a lot of good, exciting stuff coming. Eric Topham, thank you, sir.
Thank you very much, Mike. Yeah,
you have a
real
beautiful
pleasure.
day. All right.
Cheers. Take care.
Bye-bye,
Thanks,
everybody.
everyone. Thank you.